All right, so really we're just, our formulas, just from, so I can get them copied from the other page. We're on page 125 in the notes. The formula is the mean of x bar. This is the sampling distribution of the sample mean, was just the mean of x, whatever the true mean was. Or you could just say it's mu, whatever it's the true mean. Okay, and the standard deviation of the sample mean from the previous page is the true standard deviation divided by the square root of n, how many are in your sample. And again, n is the number of people in your sample, or the number of apples in this case. So, suppose the weights of apples are approximately normally distributed with a mean of 200 grams and a standard deviation of 35 grams. Okay, so the x represents what? Weight of apples. This is actually completely review exactly like we did in chapter 6 for the first part. The second part is the sampling distribution part. So weights of apples. Okay, and x is normally distributed with a mean of 200 grams and a standard deviation of 35 grams. So I could draw for part A, I can draw this picture. 200 goes in the middle, and then 235, 270, 305. And then let's see, 165, 130, and 95. So that is our standard normal curve for weights of apples. What probability do they ask us to find? The probability that x is what? At least. What does at least mean?
Greater than 8.
Greater than or equal to 220. Okay, on a test, you're going to have to be able to translate, and we're only picking one apple. So what's n here? 1. So we're only picking one apple. Okay, if we're only picking one apple, does the standard deviation or mean change based on our formulas here? No, because you'd be dividing by the square root of 1. What's the square root of 1? 1. Okay. So in this case, we don't need to adjust our original information because we're only taking a sample of size 1. It's when the sample size gets bigger that your standard deviation will change. Okay. So the probability that x is greater than 220, here's 220 about right here, and I want a shade above that. So how am I going to figure that out? Very good. I'm going to do NCDF. And what is my lower bound? 220. What is my upper bound? Okay, at least 999 you have to put in. What is my mean? No, my mean, 200. My standard deviation, 35. And what do you get for your probability? .2838. Anyone agree? 0.2838. Okay. So there's a 28% chance that if you pick up just one apple, it's going to weigh at least 220 grams. Okay. Now that's old normal model stuff. Now new sampling distribution, now instead of picking one apple, we're picking 25 apples. And what are we going to do with the weights of those 25 apples? We're going to find their average weight. We're going to find their average weight now. So this is the sampling. We've done we've taken 25 apples. We've taken a sample of 25 apples and we found their average weight. Do you suppose the average weight of 25 apples has as much of a chance as one apple to be over 220 grams? You think it has a bigger chance if you take 25 apples' weights and average them? Wouldn't you expect the average of 25 apples' weights to be closer to 200?
Yeah.
I would expect it to be fairly close to 200 because that's the true mean, okay? The one apple, if you just pick up one apple, couldn't it have just been that one really big apple? It could have been. But is it more likely that out of 25 apples you'll get 25 really big ones? Probably not. So what I would expect in this case is that our probability is going to be less. I mean, let's see if it's true. So this time we want to know what's the now this time what's n this time. This is the major difference. This is really the only difference. What's n this time? 25. Okay.
Then do we have to adjust all of our?
Just the same.
Now we have to adjust our mean and standard deviation, but really, really what's the only part of the formula that involves n? Standard deviation. Now what do we have to check for first though?
If it's greater than 30, or,
Don't we have to check the conditions first?
oh, yeah.
Okay, we have to check the conditions because now this is a sampling distribution. We have collected a full sample, not just a sample of one, okay? So I'm going to check my conditions. So what's the first condition you have to check? Randomization. You can just write random for that, or, I mean, you don't even have to write random. You can just say it's stated as a random sample. Don't they say random? So you can just say it's stated as a random sample of apples. Okay, again, this is how you get it in the context, is by referring to, like, I'm picking apples, voters. Just use a word from your problem to describe what you picked. So it's stated as a random sample of apples. Okay, the second condition is the independence condition, or the less than 10%. Okay, so what do we have to assume here? 25 is less than 10% of all apples. Okay. All right, next condition. What's the next condition?
Either n has to be greater than 30, or you can check it on a calculator to see if it's already.
Very good. So large sample size. So n is greater than 30 or normal already. So is n greater than 30? No. So I crossed that condition out. It doesn't go with that one. Is it from a normal population?
Yes.
Yes. How do you know that?
Is there already for
Okay. Okay. Stated as a normal. Stated that apple weights are approximately normal. Okay. So now that we've checked our conditions, what does it mean since we checked our conditions? We can use a normal model, okay, on this sample of size 25. Okay, a sample of 1, apple weights are normally distributed, but if I'm collecting a whole sample of 25 and that's a new distribution, okay? So now I can use the normal model. So now my apple weights, so this is X bar, okay, X bar. It's the sampling distribution of the sample mean. Wasn't that the title of this notes today? We took a sample and we calculated the mean, the average weight of these 25 apples. So X bar is approximately normal with a mean of whatever the true mean is,
200.
and a standard deviation of the true standard deviation divided by the square root of n now. Okay, so we've got 200 and what? 7. So, wait, what was 35 divided by the square root of 25, which gave us 7. Okay, good. All right, so 207 grams. So what did it actually do? What happened to the standard deviation when we asked more people? It got smaller. Okay? It got smaller, which puts everything is closer to the mean now. So now my new normal picture for this is 200, and now what's the first standard deviation mark? 207. and 214 and 221 and 193 and 186 and 179. I'm drawing purposely bad normal models for those people that just think they can't draw a normal model and stress out about it, and it's no big deal, okay? All right, so now, all right, so now where's the are we asked, the probability question here is
So it'd be the
That X
left
bar
of
is greater than
that X bar is greater than or equal to 220, right? The same question we just answered above, but for 25. So now here is 220 this time. Notice what happened to it. It's farther away because the chances of the average weight of 25 apples weighing over 220 grams is pretty slim now. So now, what do we do to figure this out? NCDF. The only difference, our lower bound is still 220. Our upper bound is,
9,991.
okay, infinity, positive infinity. So at least 3 nines, more than 3 nines, some bigger than 220. Okay, and then my mean is what? What's my mean? 200, but what's my standard deviation this time? 7. And what do you get for that probability? 0.0021. So a very slim chance that the average weight of 25 apples will be more than 220 grams. All right, so now let's move on to this very last little question. Suppose that the population of residents of a local town has a mean annual income of $50,000. So mu is 50,000. That's the true mean. And a standard deviation, the true standard deviation is 35,000. If a random sample of 100 residents is selected, N, what is the probability that their sample mean, that X bar is within 5,000 of the true mean? X bar is within 5,000 of the true mean. So that actually means between what two numbers? 45,000, that X bar is between 45,000 and $55,000 per year. Okay, so we have our information, we're looking for this probability. What do we have to do?
You gotta see if it's normal.
See if it's normal. Check the conditions. So you're going to have to check the conditions again. So if I check the conditions, we'll just do this fast. I have to do it fast because I only have 2 minutes left on my video. So check the conditions. So if I check the conditions, 1, is it stated as a random sample?
Yes.
Yes, so random, I'm just going to write yes. Okay, you would write it's a random sample from the town residents. Okay, 2, is it less than 10%? Is it independent? Yeah, 100 is less than 10% of the whole town. We're going to assume that. Okay, yes, there's always those what ifs. Okay, and then 3rd, is n greater than 30?
Yes.
Yes. Okay, so we can stop there. So what that means for us, that means that X bar is normal, and the mean is the true mean. And how do you calculate the new standard deviation? Standard deviation over what? Square root of n. I'm just writing the formulas down now.
35,000.
So X bar is normal with a mean of 50,000 and a standard deviation of 3,500, good, 3500. So then our normal model, we've got 50,000 in the middle, and then that would be like 53,500 and 57,000 and 60,500, something like that. Okay, and then below would be like 46,500, 43,000. I can stop there. Because within 5,000 of that, isn't that from here, 45K to 55K. So what do you type in?